I'm Peter from Team Tether. Here's an update on some of the stuff we've been working on.
Our project, we're going to be using the client-server model. It's the most efficient way to complete our architecture modeling because for all our clients are going to be our devices that are going to use the app. And so each client needs the database each time. And the database stores our stored locations. And so those locations need to be accessed by the client, and so we have one server, and the client sends the data to the database, and then the database returns the data back to the client when it's requested.
So this is the sequence diagram for one of our core use cases, the store car location. Basically, we have the user starts a Tether session, and essentially they interact with the Tether user interface. The interface then calibrates the GPS and prompts the user if the GPS location is correct, and the user must confirm that. That's described here by these boxes. So the calibrate GPS step will loop 5 times, and it's conditional on the 5 times and the user not accepting. And these represent the if-then or if-else cases. We'll start with the calibrate fail. So the app will calibrate the GPS, and if the user denies that confirmation, then Tether will keep prompting the user. If the user accepts the calibration, then Tether will accept that location and then store that location into our database. Our second major use case is essentially view car location. It's very similar. Once the user is ready to finally view or see or navigate to their stored car location, they will let the interface know that. And then the interface will essentially communicate with the database to retrieve that GPS location. And so the interface will then communicate back to the user the location of the car in augmented reality with a visual cue. We have essentially what is an option for the user. If they end their session early or if they end their session at all, that does represent an option on the user's end. So if they end their session at all, then it will actually delete the GPS location from the database. If they don't end their session at all, then it'll remain.
So the way we are going to be able to have the user mark their car is using the Hammerstein formula, which is used commonly in navigation systems. So here we have our phone coordinate plane. The z-axis represents the front of the camera. So z minus is the front, z plus is the back. The y-axis, y plus, y minus. X plus is the right side, and X minus is the left side. So if a user is looking directly at their car, then we can easily calculate the transform vector we need to translate the 3D marker onto the car. And we do this by getting the distance from the user and their car. We do this using both of their GPS coordinate locations, and we input it into the Hammerstein formula to get the distance. So the translation vector would be 0, 0, d, since the z-axis would be in front of them. However, if they were looking away from the car, if they're not looking directly at their car, then we would have to calculate the bearing first, the bearing distance, and then we would have to calculate the Hammerstein distance. This would be the translation vector if they were not looking directly at their car. So we would have to find the bearing distance, which would be the x-axis. And then we will assume that we're not accounting for elevation right now, that will come later. So the y-axis will be 0, and then the z-axis will be the Hammerstein distance.
Add project to Firebase, click add app, click iOS, register the app. You will download the Google service info, drag it into the Tether app within Xcodes, which will allow you to establish the connection between Firebase and Tether. Click next. You have to download and install pod, so you want to go to your terminal, reference the database, and then Afterwards, you will go to Tether on Xcodes and you will go to app delegate. You want to import Firebase and import GeoFiber here, which will allow you to reference the database. Within the app delegate class, you want to add Firebase app.configure, which will initialize the database. Once you do so, you can create the reference for the actual database, which will allow you to store and load the data. Here we will go to database and then click real-time database. And this is where our data is currently stored.